We've studied angle bisectors in triangles in Chapter 5 when we talked about the in-center and things like that, but an angle bisector also does something special with triangles in terms of proportionality. There is a theorem that doesn't really have a name, but it says that if you have a ray bisecting an angle of a triangle, then that ray divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides of the triangle. So what we have here is an angle bisector. Ray CD is bisecting angle ACB. So what that means, if I put some letters on here, let's do A, B, C, D again, because I think that's easier to see. Okay, that means that it divides the side of the triangle proportionally with the other two sides that are not being intersected at all. So A is to C as B is to D. Okay. The one way that I actually set these up, I always like to do the segment of the side that's, so like let's say, okay, this side of the triangle is divided into two parts, right? You have this upper side. Well, that's going to be in a ratio with its adjacent side of the triangle, and C will be in a ratio with its adjacent side to the triangle. That's the way I like to set it up. So I like to do A over B and C over D. Okay, you'll see that that works out the same, right? Because when we solve the proportions, we're still multiplying A times D and C times B. Okay, so now here's an example. We're asked to find BD and CD. All right, now you'll notice you're given all three sides of the triangle. But we want to know, okay, how is BC divided by this angle bisector? So since BD is the segment I'm looking for, I'm going to call that X. Now, if BD is X, and I know that the whole segment of BC is 14. How could we write an expression to label the length of DC? Right? So for example, let me put some numbers on it to help you think about that. If the whole segment is 14, then let's just happen to say that BD is 10. Let's just say BD is 10. Okay? How long would DC be? 4, right? Because you would do 14 minus 10. So you do the whole segment minus the part, right? Okay, so now let's think back in terms of X. So if this side is X, to get DC, we're going to do the whole, which is 14, and subtract the part of X. So DC is 14 minus X. Now, we know that the sides are divided proportionally with the adjacent sides of the triangle. So the way that I set this up, I like to do X over 9, so this side with its adjacent side length, and then this side that's divided by its adjacent side length. Okay? Cross multiply and solve, we get 15x equals 14 times 9 is what? 126 minus 9x. Add over, so we get 24x equals 126. Lovely. We get a decimal, which is 5.25. So that means that BD is 5.25, and if we do 14 minus 5.25, we get 8.75 for DC.